Good morning, guys. Hey. Welcome to BriForum. Welcome to the first session of the first day at BriForum. So, you guys saw Brian's keynote just now, most of you. He's talking about how VDI isn't quite as shit as it used to be. Oh, by the way, I'm British, I swear. I'm sorry, but it's going to happen. So if you don't like it, then, you know, it's going to happen. So, how many people is their first time at BriForum? Wow. Wow, almost everybody. So you don't know not to come to my sessions yet, right? How many people have a VDI deployment that either they're thinking about, or is already there, or is in pilot, something like that? Okay, most people as well. Zen Desktop, hands up. Okay, View. Okay, fairly even mix, good. So I think BriForum in the past has been accused, somewhat unfairly I feel, of being a Citrix-centric conference. Probably because Citrix has been doing some kind of desktop virtualization for much longer. But I think that's reflected in the crowd. I'm very happy to see that. So out of all those people who've got some kind of VDI, who's on vSphere? Everybody, right? You wouldn't be here if not. So we're going to talk about storage improvements in vSphere 5.1. We're going to mention some of the features that were available in earlier editions, but if they've been improved or changed in 5.1, then we'll cover them. I'm not going to cover every single storage improvement in vSphere 5.1, so I've essentially cherry-picked out the features that I think are relevant to a desktop virtualization project. And there's some very good ones in 5.1. So if I've missed out stuff that's relevant to vCloud Director, that's fine. My name is Jim Moyle. You can find me on Twitter at Jim Moyle, and I've got a blog at www.jimmoyle.com. When I was reviewing my slides this morning, I realized I'd actually spelt my own Twitter handle wrong. So I'm glad I found that this morning. I work for a company called Atlantis Computing. We're sponsoring BriForum. We've got a stand just out there if you want to come and talk to us about some of the stuff that Brian mentioned in his keynote. I'm not going to be covering any Atlantis-specific stuff here, but come and talk to me afterwards if you want to. I'm also very proud and privileged to be a member of the CTP program. Great group of people, and many of whom are presenting here over the conference. Why do we need storage enhancements in the hypervisor? Surely storage should do that. Well, you probably heard somewhere around the line that there is a slight storage issue with VDI. So, essentially, what's happening is that storage features are moving into the hypervisor, and hypervisor features are moving into storage. Because the sort of monolithic storage versus hypervisor, and that split is now becoming much fuzzier as you get snapshotting, cloning features offloaded to the storage, and you're getting caching moving into, and other things moving into the hypervisor. Mainly because of what I call transient data. So a SAN is made for capacity and redundancy, resilience. What we've previously been storing on the SAN is page files and other things. This is not data that needs to be redundant or we need to allow for capacity with. So this data is transient data. So this can now live much closer to the hypervisor and can be cached in the hypervisor. So vSphere's got the VSA, the View Storage Accelerator. Citrix has got IntelliCache, and Hyper-V3's got, I can't remember the name of it, but it's now RAM cache in front of their shared storage. One of the big problems with VDI is what I call the early bird syndrome. So if you've got a traditional VDI infrastructure and you've got, say, a SAN with 20,000 IOPS on it, and you've got 1,000 concurrent users. If your first guy comes in at 7 a.m. and he's the first one to log on, he's got 20,000 IOPS. Woo! At very low latency. So he's going to be one happy camper. As the day wears on, and it gets to sort of 2 or 3 in the afternoon, that isn't the case anymore. As his 999 colleagues log on, he's now got 20 IOPS. He's now very sad. And this variation in user experience is a killer, because users can get used to anything as long as it's consistent. Yeah. So, I mean, I've walked into customers, and they've had a horrible VDI user experience, but it's been horrible forever. And it doesn't generate any help desk tickets anymore. Whereas if you're great in the morning and much worse in the afternoon, you get that kind of, oh, how's your VDI today? Mine was really fast. No, mine's gone slow now. Oh, what's wrong with this thing? You need to be able to control your user experience. The other one is what I call a noisy neighbor. So essentially, quality of service in a hypervisor has not really existed for storage in the past. Now, hypervisor technology is built on fair use of the CPU cycles. I mean, that's what virtualization does, essentially. And after we got fair use of the CPU resources, we got fair use of the memory resources. And both of these resources are on host. So you're not sharing them across your enterprise. You're not sharing them across your 1,000 users, which means that it's much easier to control. Now, without quality service, it means that if one person does something bad, for instance, they run a full virus scan, or the help desk runs a full virus scan to try and fix their machine, they're going to steal all of the I/O from all of their neighbors. And again, you're going to get a horrible variation in user experience. So even if you've sized correctly, these are two problems that you're going to have, the early bird and the noisy neighbor. I'm going to talk a little bit about sizing. So this is, I like my graphs, by the way. If you come to my talks, I always have graphs. So this is 1,000 users, concurrent, on Windows XP, on physical hardware. So you're candidate for an upgrade to VDI. This is the IOPS requirement for them for a single day. So 7 a.m. to 7 p.m., and we're going up to 60,000 IOPS on the y-axis there. So this is a government department. So they allow flexible working. So there is no log-on storm. So they log on from about 7 a.m. to about 11 a.m. This bit here, that is the lunchtime log-on storm. One interesting thing that you notice about this is they all come into work at a different time. They'll go home at the same time. How does that work? So we can see that we're peaking there at about 48,000 IOPS. We're not going to supply 48,000 IOPS to this enterprise. So if you look at a lot of documentation, say Windows XP, 6 IOPS per user. See that all over the place. So if you average out this over this day, that is the average. It does come out about 6,000 IOPS. So 1,000 users, 6,000 IOPS, we have 6 IOPS per user. Does anybody see a problem with providing 6,000 IOPS to these 1,000 people? All right? Sizing on average is shit. All right? And everybody says, but doesn't it all equal out? You know, when somebody's using some, somebody else is not using the rest, and you know, then we can size an average. Absolutely not. You cannot. So at this point here, during the busiest part of the day rather, you can guarantee, if you size an average, that 100% of your users has a worse than physical experience. And that's a horrible thing to have to realize about what you've sized and what you spent. Sizing an average is a bad thing. This also works for CPU and memory, but particularly important for storage. This is another IOPS graph, but this time it's a single VM. This is a single VM. It's actually stored on the Atlantis virtual appliance. So that means it's got as many IOPS as you like. So there's no bottleneck for I/O here. So that's going up to 5,000 IOPS there, and just time along the bottom. This is another reason why average is very poor for sizing. So what we see is this is IOPS for a single VM. Yeah, this is just perf mod. If you've got an SSD in your laptop, you can run this exact same test. All right? So when you first, especially on the first application open, you don't want to do it on a second application open because that's already stored in device RAM. So your first application open. So this is just a script to open a whole load of applications. And what we can see here is that we're bursting up sort of 3,000 or 4,000 IOPS on a single application open. So why is this happening? Well, Windows is actually doing exactly the right thing. It's trying to provide the best user experience. So this explains why SSDs are so good, because they provide you with burst capacity. You can burst up to thousands of IOPS. Average is useless for user experience. What you need to provide is burst capacity on I/O. Because Windows will try and do the 8,000 reads and writes to open Excel as fast as it possibly can. If you give it 4,000 or 5,000 IOPS, that's going to happen almost instantly for the user. Excel is not frivolous with its reads and writes. It still has to do them. So if you lower the burst capacity, it's just going to take a lot longer to do that action. So these are all things to bear in mind when you're sizing your VDI project. Some of these problems that we've just had a look at are addressed in vSphere 5.1. So the hypervisor is middleware. It sits in between the storage and the user. So it's in a great position to put intelligence around that I/O stream, because everything goes through it. So if you can put stuff like quality of service, some form of that, into the hypervisor, it's in an excellent place to do that. I just want to call out a friend of mine. So this guy's called Cormac Hogan. I don't know if you know him. He is the VMware storage evangelist. He's a great guy. Helped me out a lot with this presentation. It is strange, I don't know if you noticed, but if you're going to talk about virtualization and storage, it appears you need a ponytail. Don't know why that is, just one of those things. If you want to have a deeper look at the stuff we're going to talk about today, Cormac's website and Cormac's Twitter feed are a really good place to start. So one of the white papers he wrote is the basis for a lot of the information in this talk today. If you want to tweet at VMware Storage, because I know he likes the kudos that I'm giving him, feel free. So we're going to run through basically a list of features, right, and put some opinion around it. So if you guys are really quiet and don't ask any questions, we're going to finish earlier, because once I've run out of features, we're going to stop. So VMFS-5, excellent. So VMFS-3 was getting a bit tired. VMFS-5 tries to address some of that. I'm not going to bother about a lot of these, but unified block size. Excellent, excellent. So unified block size means that if you're creating a 2 terabyte you're not having to use 8 meg block size anymore. So this is much more efficient. So small file support, again, efficiency.
Quick question on that.
Yeah.
On the subblocks, does that imply they have some kind of subblock dedupe, or they're just exposing subblocks?
No, they're just exposing subblocks as the grain size, so there's no dedupe in there. So one of the nice things is that if you're upgrading to VMFS-5, it is non-disruptive. You do not have to storage vMotion all your stuff out before you upgrade. So you can allow VMs to remain running on the data store while it's being upgraded. But there is a problem here. And that is that if you do an upgrade from VMFS-3 to 5, you actually lose some features. So if you're going to go to VMFS-5, I actually do advise that you do a storage vMotion and then change your file system and don't do an in-place upgrade, unless you've got very good reason not to. Because you lose your unified block size and your starting sector has changed, so you could still have block misalignment issues. I'll talk a little bit about what they call view storage tiering. So in a stateless view VDI environment, you can pick where to put your replica. Now, for people that aren't familiar with View, your replica is your golden image. You can either put your replica on each data store, or you can centralize it. This is good for different environments and depends on how you configure as to which one you prefer, but I really like having the choice. So if you're using PVS, Citrix Provisioning Services, your only choice is to have a centralized golden image. If you're using MCS, your only choice is to have a distributed golden image. This is horrible that you've got to completely change technologies depending on what architecture you want. I'm hoping in the future that will change. And that the ability to have a centralized golden image comes into MCS. I think it probably will. One of the things that happened, it's not really a vSphere 5.1 thing, but while we're talking about view data stores, vSphere 5.2, View 5.1, 5, and 5.2 gives you this choice for your data stores. You can set it to non-conservative, moderate, or aggressive. Now, there is a change in View 5.2, which is really important. Aggressive used to mean don't check. We'll let your decision handle your storage over commit. Aggressive now means 15 times the size of the data store. That's a lot. But if you've got a really good deduplication on the back end, it can really bugger you up because you can get better ratios than this. But you're not allowed to because VMware View won't let you deploy without being underneath this 15 times. Again, I think that's going to change in the future. They're going to move back to the previous setting in 5.1 so that aggressive means don't check. So Citrix don't have this at all. They just leave it up to you and your architecture and the storage subsystem to be able to pick your overcommit. So I think that this is a horrible setting in View. What does this mean? What does aggressive mean on your data store? Yeah, these are not picked out in the UI. They just get this choice of, so what conservative, aggressive, what I'm going to stop punching my storage? I think they should take this out altogether and leave it up to us. So while we're talking about previously about where View stores its golden image. Previously, there was a limit of 8 hosts per cluster for your View deployment. The reason being is that there was a VMFS limit of 8 different hosts accessing a single file for read-only purposes. And your replica is your read-only golden image. So the fact that no more than 8 hosts could access that file means you couldn't have any more than 8 hosts in your View cluster. So the new change is 32. So in vSphere 5, it was actually NFS could handle 32, but VMFS could only handle 8. Now NFS and VMFS can handle 32, and if you're on View 5.2, then your cluster size is now able to be 32 rather than 8. So if you have a large deployment, then this is really handy for scalability, for administration, et cetera, et cetera. So VAAI. I really like VAAI. It works great. Apart from the fact that just over a quarter of supported storage vendors or storage editions support VAAI. You can actually do this on the HCL. You can now, there's a new thing where you can search whether storage has got VAAI or not. And it's about 700 different bits of storage that support VAAI. Probably because it's not a vSphere function, essentially, because the storage vendors have to write software that they then plug into the hypervisor. So whether it's not worth the effort for them or I don't know, but VAAI is not available for as many storage as storage I'd like. This is the only change between 5 and 5.1, thin provisioning unmap. We'll go into that into a little bit, into a lot more detail in a little while, but it's really, really important. You know there's vCAI as well, View Composer Array Integration? There's even less bits of storage that support that. It's actually just over half of, just under half, sorry, of storage on the HCL for 5.1, which supports VAAI, so it's getting better and better. But be careful. So, thin provisioning primitives, out-of-space condition handling. So, there's a new alert which comes in, which means that you can tell when your over-provisioned storage is becoming under pressure. Dead space accumulation and reclamation. So that's the next slide. So dead space is space that after a storage vMotion is still assigned on your data store. So effectively, you're looking at your data store, it's reporting full, but you look at your VMs on there and you realize that they're not taking up all the space. Where's all your space gone? So it's dead space. So now, through VAAI, you can do dead space recommendation. It's only supported by a manual vmkfs tools command in vSphere 5 and 5.1. They actually took it out of 5. After GA, they had a problem with this script. And now it's back in 5.1, but it's not surfaced in the GUI. You have to run it on the command line. There's a KB about the whys and wherefores of that. But you're now able to reclaim this dead space, even if it is just a command.
Jim, this is the script that issues VAAI commands to a storage platform.
Yeah, well, it's a vCLI, VMKFS tool, so it's actioning on the, originally on the VMFS data stuff from within the hypervisor, and then the VAAI software within the hypervisor then takes that command and takes it off to storage, exactly.
Is there any mechanism or plans to get that up into the guests so I deallocate in Windows?
We'll come on to that. That's a very good question. So the question was, is there any way that we can surface this bit of functionality within Windows? Yes, so as long as they've got VAAI, then this will work. VCI, View Composer API for array integration. Available in View 5.2. So it works only on View's link clone technology. And it means it's offloading the link clones onto the SAN. Very good. It means that it's a lot faster and a lot less wasteful of resources on the hypervisor layer. Actually, this is another thing that works for vCloud Director as well. So a lot of these updates, you'll notice, are around link clones. And that's because VMware made a big effort to improve their link clone technology, mainly because of vCloud Director, I think, to make vCloud Director better. But it has a really good knock-on effect for us in the desktop world because View uses link clones as well. So, storage I/O control. Now this, Sonny.
Is there anywhere where we can actually find a document that describes which memory optimization can be done for the Zen desktop on vSphere versus which ones can only be taken advantage of by
So the question is there a document we can find anywhere which optimizations are available for View compared to what are available for Zen Desktop? I.e. the question is all this stuff I'm talking about available for Zen Desktop as well? Most of it is not at the moment. There isn't a document that I know of, but most of this stuff is not as yet available for Zen Desktop. But these are hypervisor features that are APIs, or at least some of them are, that Citrix will be able to take advantage of in future. Some of them depend on Composer being there, have a prerequisite for View Composer, but we'll go into that later. This one is available for both. So storage I/O control, as I say, is a solution for your noisy neighbor. It's quality of service. So previously, you could have two different hosts accessing the same data store, and you want your Exchange or your online store to have priority, but in fact, your data mining application is stealing all of the I/O, essentially. And as it steals all of the I/O, your data store becomes congested, and your VIP applications have issues. This is not a great situation to be in, because you want your VIP applications to have priority. So you can get highly variable performance, highly variable user experience. So this means that in your desktop, somebody doing something can steal somebody else's I/O. We don't want to have that. So we want to be able to guarantee your I/O performance. So storage I/O control. It uses the same mechanism. So if you edit your settings and go to your resources tab in your disk, you see on the very right-hand side, there's a little drop down. And you can enter a number to limit the IOPS. So it's essentially creating an artificial bottleneck on that particular VM. This is really good for demonstrating why people are stupid about IOPS in VDI, actually. If somebody comes up to you and says that 20 or 50 IOPS are good enough for VDI, get a persistent VM with Windows 7 on it, limit them to 20 IOPS here and see how they like it. You'll find that decision is quickly changed. Actually, the lowest you can go on here is 16 IOPS. If you are going to try this and test it, I do not recommend you go below 50. Because if your VI client also happens to be in this VM, it's a real pig to actually get a VI client open and change it back.
How's it at 50?
It's still crap. It's all right once all your applications are open, because then everything's loaded into memory, right? And if you're just sitting there doing word processing or using Excel, then actually it feels fine. But anytime you try and do something that's not just sitting there, it becomes a real problem. like opening an application for a first time. And then you notice that your user experience goes down the pan. So this is also what I was talking about burst capacity, allowing burst capacity for those different actions.
Jim, does it not be fact that it's overlooked all the time? Is just what does an average computer have today? A crappy laptop takes 80.
Yeah.
So there's your baseline. Now, if you're on a relatively mediocre computer, probably giving 80, just based on the internal drive.
So.
That gets missed.
So Steve was just saying, for the benefit of everybody else, that a fact that usually gets missed is that your average laptop or desktop has 75, 80, 100, 120 IOPS. And everybody is moving to SSDs in their laptops, right? I have an SSD in mine. If I accidentally threw my laptop under a bus tomorrow, and Atlantis Computing said, here's a new laptop, and I'd say, does it have an SSD in it? And they say no, I'd say, fuck off. Because it makes that much of a difference to your user experience and your productivity and what you can do, is having that burst capacity of I/O. And that, going forward, is going to be the user experience that people expect. So how many people here have got an SSD in their laptop? Almost everybody. How many people is looking jealously at everybody else? Anyway, back to storage I/O control. So effectively what's happening is that without any quality of service, you've got queue depth per host, and that's shared between your VMs, and then as it comes out to the storage has no way to say this or that I/O has priority over another one. So storage I/O control is a way to enforce quality of service, and it works at a cluster level. And it means that you can assign shares to your VMs, and it means that you can then assign your queue depth to prevent congestion on your storage layer. It means that you can get a better user experience by guaranteeing performance to your VMs. So be careful you don't set it too low, though, because then you have the problem with the burst capacity. Storage I control used to be just turned on when you said so. And what happened is that it would then have to collect a whole load of stats about your storage before it could make intelligent decisions about it. So it's now turned on in stats only. So it doesn't enforce throttle, but it gathers statistics so that if you do turn storage I/O control on, then it's already got the information it needs to start sharing out your storage effectively. One of the things that is much better in 5.1 is the automatic threshold computation. So what this means is that the hypervisor would judge that a storage is congested and has issues if the latency to it was over 30 milliseconds. 30 milliseconds is a lot for a desktop, by the way, of latency to your storage. People talk a lot about IOPS, and really, they don't know what they're talking about. They're really talking about latency. And it's the the latency which is your key metric. Now, high latency is usually caused by lack of IOPS, but it can have other causes that will make your user experience rubbish. So you need to look at your latency. Now, Microsoft say that under 10 milliseconds is good. Between 10 and 25, in their words, is warning, and above 25 milliseconds is critical. And VMware have said that they take this 30 milliseconds as a critical threshold. I would suggest to you that for a good user experience, you want to be looking at under 5 milliseconds for your desktops. Remember, this is an interactive workload. If it's a server workload, who cares if we've got slightly more latency? For an interactive workload where users are pressing stuff and they expect to see it back, very, very important to have low latency. So instead of setting it at 30 milliseconds, so there is a new way to model this. So this means that storage I control will determine the peak throughput. So here, it will determine the peak throughput, and then at that, it will throttle it back to 90% load, and then it will take the latency at 90% load and use that as your judge of when you're congested. The reason why this is really good is different bits of storage. For example, SSD, if you've got 30 milliseconds of latency on SSD, it's more than congested, it's completely gone. So you want to have better warning of SSD congestion than 30 milliseconds. So you want to lower that down, and this will do this automatically for you. You can still do the old way, and you can still set it manually if you want to, but I would suggest that the automatic generation of this is much, much better. Storage I control should not be used for tiered storage. Very important. So if you have storage tiering, switch storage I/O control off. Because effectively what's happening is that you're trying to do the same thing on the hypervisor and the storage side. So because how the hypervisor judges this is it shoots a whole load of I/O at the data store, and then measures it, and then sets the value, and then that's the value it has. If you have storage tiering and you're moving that data around from a flash tier to 15K spinning disk to 7,200K spinning disks, then vSphere will be wrong about where it's set the threshold. So if you have storage tiering, do not use storage I/O control. Very important. So storage DRS. Storage DRS was introduced in vSphere 5. Automatic selection of the base data, so for your initial VM placement, avoiding hotspots, disk space imbalances, and I/O imbalances. So without this, your placement used to be based solely on CPU and memory. That could create some really odd conditions of hotspotting for your VMs on a rebalance or recompose. So it meant that you could have very congested storage on one host and unused storage on another host. So the advantage of storage DRS and placement means that not just CPU and memory are taken into account, but storage performance as well.
Jim, does this have an element of storage motion, or just where it plays at the end?
So storage DRS does both, yeah. So you can turn it on so you can get it to move VMs around as well. So once you turn on storage DRS, it will optimize your placement of your VMs for, again, not just CPU and memory, but for storage as well. So excellent stuff. Having said that, is DRS of any kind useful for VDI? Because you're probably going to have a relatively homogeneous state. Because your VMs, whether Windows 7 or Windows 8, who's doing Windows 8 VDI? Yeah, that wasn't a great success, was it? You remember what I said about VDI being a very interactive workload? It does not peak and then stay at that peak and then move down. It spikes. And it spikes in milliseconds or seconds. So if you're doing DRS and you're saying, well, I'm going to measure every 5 minutes, which is the minimum, and then I'm going to take it and then I'm going to move it somewhere else, whether that's a storage vMotion or a vMotion, yeah, this is a desktop. You could be going from high intensity to no intensity virtually, almost instantaneously. So you'd very, very rarely get that kind of consistent load profile where DRS is useful. So in the VMware documentation, you will actually find conflicting advice for using DRS. Some will say it's best practice and some will not. I think that the only possible time that DRS is useful for VDI is placement. And if you have persistent desktops with where you know that you've got some people that are doing CAD or doing data mining or whatever, and that is a consistently higher load profile. And then it might be useful. But in general, I think it's not good for VDI. So Storage DRS introduces a new data store correlation factor. So it checks that these data stores are individual bits of storage. So it is possible to have data stores which are backed by the same spindles. So when it does its tests against these bits of storage, it will now notice if the data stores have exactly the same storage profile, and it will figure out that these data stores are actually backed by exactly the same spindles. So it's getting much more intelligent about the quality of service. So this was previously available in Varsa because Varsa surfaced these up from the bottom up, and now it's just taken entirely by the hypervisor layer. Nobody uses Varsa. It's, anyway. Anti-affinity rules will then take this correlation into account, so it won't put, where you've got anti-affinity rules to say that these can't live on the same data store, it will then use this correlation to realize that these two data stores are really the same bit of storage, and it will then take anti-affinity rules into account. Storage vMotion. Previously, if you had multiple disks on a VM, it would happen serially. So it would move the first disk, then it would move the second disk, etc., etc., etc. Now you can do up to 4 parallel copies of the disk at the same time. So it will start all 4 storage vMotions at the same time, and then when the first one completes, if you have a 5th one, it will start the 5th one. So now storage vMotion is much faster and much better. So related to VDI, I guess you could say, if you have storage vMotion PVS machines, which usually have a couple of disks, then that's going to happen a lot quicker. SSD. Previously, vSphere wasn't very smart around SSDs, but the prevalence of them in the enterprise now means that they have had to get a lot better. And there is something called SMART, which is a horrible made-up acronym. I hate when people do that. And now this is now surfaced up into vSphere. Not into the GUI, though. Only available again through command line. Really important, media wear-out indicator. So SSDs in general do not fail disastrously as spindles do. They gradually lose performance. So it means that as cells become unusable on the SSD, then your IOPS will gradually decrease over time. So this is important when you have a look at your SLAs with your vendor and your support agreement with your vendor. If they promise to replace a failing drive, at what point of this SSD wear out do they consider it to have failed, then you get a new one? You know, is it 95% of the original capacity, or is it 20% of the original capacity? So you need to have a look at that when you're looking at your SSD support agreements.
Jim, is there any kind of standard when SSDs report something back that you can read? I've never heard of anything like that.
So the smart stuff is actually the standard.
Okay.
So that's available on almost all the SSDs. VMware is now able to take that standard and report on it, whereas previously it didn't have the intelligence to look at it. There also will be in the future a pluggable architecture around this, so SSD vendors, if they want to be able to surface more metrics about their SSD, they can, again, like VAAI, have a bit of pluggable software you can plug into the hypervisor and you'll get better reporting. In regards to your question before about is it possible to surface this dead space reclamation into the OS, this is it. It's what they call space-efficient sparse disks. My favorite bit of storage enhancements that came along with 5.1. Great bit of technology. So it means that stale, stranded data in the OS can then be reclaimed. So why does this happen? So really, this is NTFS's fault. or rather, again, is Microsoft doing exactly the right thing for the user experience, but it's modeled off of a non-virtualized OS. So if you delete a file, this is what the file blocks look like to storage pre-file deletion. This is what the blocks look like to storage after you've deleted them. There is no difference. All that Windows does is mark those blocks available to be overwritten. The storage cannot tell that this is no longer valid data. So this has a really big consequence for linked clones or thin provision disks, because what Windows will do, if there is unassigned partitions, unassigned places in your partition, it will use those first rather than overwriting something else because it's faster. So over time, any block-based delta will increase in size to the same size as your original disk, not just the data, the original disk. Now, how long this takes is a factor of what the workload is. But it means that if you have, say, your VMware View Link clones, and you think, wow, I've just provided some nice SSD storage for my link clones, they're dead fast, my users are happy, and you don't recompose or refresh your desktops, what happened was those VMs will grow to the same size as the golden image disk. So you will run out of space on your SSD. This is a big problem for large View customers. This is not just a View problem, this is just a Windows problem. So essentially, what we need to be able to do is we need to be able to some way to tell the storage that that space is no longer needed. And space-efficient sparse disks is the way to do this. So essentially, it initiates a call to VMware tools to scan the guest OS file system, mark unused blocks as free, run a SCSI unmap command in the guest OS to tell the virtual SCSI layer in the VM kernel to mark blocks as free. One important bit to note about that, SCSI unmap command does not work on IDE drives. So it needs to be a SCSI drive for this to work. Then Composer initiates a shrink and a wipe. A wipe and a shrink, sorry. So it then wipes these blocks of data, and it shrinks the VM down to the size of the data rather than the size of the data it was before. So it initiates the wipe, scans the file system for unused space, informs VMware kernel about the unused blocks, and then interestingly, it reorganizes the SE sparse disk to create contiguous free space at the end of the disk. Why is this important? Because it's horrible to I/O. Do not do this in the middle of the day. All right? Because it's a real strain on your storage to effectively defragment it. So it will take all of these blocks and it will move them until you've got white space, and then it will shrink down the white space at the end of the disk. So you can make sure that this only happens at a certain time of day. In the GUI, there is a way to block out certain times of day so that this doesn't happen during working hours. Of course, if you're running 24/7, then you're buggered. But if you have spare time, then you can use this feature. So here is where you can do that in the GUI. You can say, right, block out this section of time. This has a prerequisite for Composer. So you cannot do this in a Citrix VDI scenario. You also can't do it if you're not using Composer for anything else in vSphere. There is something you can do, though. Microsoft sysinternals tool called sdelete. So essentially, what this does, well, sdelete stands for secure delete. So be a little bit careful when you're using it, guys. If you have a deduping file system in the back, so if your SAN does dedupe, or you're using any kind of dedupe, you can use sdelete to reclaim free space. sdelete/z essentially writes zeros into all of the free space. And then what will happen is that when your backend storage does its dedupe job, it will then realize these are zeros and it will shrink your VM down. So If you're in a situation where you can't use the SE Sparse disk and you have some kind of DGIP available to you, then this is an alternative. Again, it suffers from the same problems that SE Sparse disks do when they're doing the wipe and the shrink. It's very I/O intensive. So again, you can schedule this using group policy, and if I were you, I'd do, you can, in the task scheduler, you can set a random time for a start, so you can set a time period for SD-Leak to run, and then you can push this out if you want to use it. That's how I would do it. Needs hardware version 9. It will not work on any hardware version below 9. Because the internal guest OS SCSI unmap command doesn't exist below hardware version 9, and there is no Windows 8 support as yet. That will obviously come soon, but having asked who's using Windows 8, nobody cares about that last line, right? Actually, we can create SE Sparse disks. There is if you want to have a play around with this, then you can use this VMKF's tools line, and you can create a sparse VMDK. If you then look inside the VMX file, you'll see SE Sparse. And then using the new VMware web client, you can then assign the existing hard disk, and it will come up as FlexSC in there. So you can actually stick an SE Sparse disk on any VM you like. Trouble is that you still require Composer to do the wipe and the shrink. So you can frig the URL in Composer then to do wipe and shrink on any disk. So this is not obviously something for production. This is obviously something if you want to go and play around with it. So if you really do want to play around with it in other situations than a view link clone, you absolutely can do it. But strictly non-production, shall we say.
Becomes a trigger task on a schedule or something
Yes.
like that.
Yes.
Goes through these machinations to create this unmap, what's used, what's unused. Any modern OS now has trim support, right? To address this specific problem.
Yep. So
Is that down the road? I mean, I know you're not VMware badge, that kind of thing, right? But you're tight with those guys, you talk with them, that's different. I mean, it seems to me that's the obvious solution to this problem.
So I have asked this question before, and they say, and don't ask me what this means, because I don't know. They said that trim is very different, and they wouldn't want to implement trim specifically into a virtual machine. You'll have to go and ask them why, I'm afraid.
So there's something under those sheets
Yeah.
that make it ugly.
Yeah. Now, I mean, don't get me wrong. I mean, if it sounds like I'm criticizing the SE Sparse thing, I'm not. I think it's great. I think that the ability to be able to keep your data the size of your actual data rather than all this ghost stuff that is caused by not just file deletion, this is also stale blocks, right? So it means that if your page file shrinks, so if you've assigned Windows to do your page file, it will vary in size tremendously. As it shrinks down, it leaves behind this whole slew of blocks behind it on the storage. Getting rid of that is an excellent thing to be able to do. vFlash. vFlash is the ability to use local SSD as a read cache. It is still in tech preview and has been in tech preview for a very, very, very long time. In the VDI world, how useful will vFlash be? Not that useful, because it's a read cache and VDI is 80% right. But at the same time, like you get in PVS, you get a static read cache that gives you small amounts of performance. You should be able to get small amounts of performance from a read cache, particularly for boot and application open, which are your two really heavy read operations within a VM. Your normal usage is 80% right, but boot and application open are very heavy read actions. I did ask VMware if they had an indicative date for the taking of vFlash out of tech preview, and they told me no. So I wasn't really expecting any other answer, but at least I asked the question for you guys.
Is it a general purpose read cache for any?
Yes. Yes. Yeah.
Go in front of NFS and log.
So it uses local SSD on the host. Yeah. Interestingly, when you do use local SSD on the host, this is the reason why it's difficult is then how do you do stuff like storage vMotion and that sort of things, yeah? Because, or even vMotion, because then you've got a local cache. So I think that the work that they have to do around it is to make sure that HA and vMotion and all those kind of things work when you've got this kind of local cache. So that's what makes it difficult, I think. So in conclusion, increasing the file share limit on VMFS-5 from 8 to 32. So in View 5.2, you can increase your cluster size to 32. Making View desktops much more efficient using SE Sparse disks, new I/O commands, and introducing Storage DRS and Storage I/O control enhancements. So it means that using these features, you can control what the two big problems I said were at the start of the talk, which is your early bird syndrome and your noisy neighbor syndrome. So excellent way to guarantee your user experience. So I hope that you found that interesting this morning, guys. And I hope you have a really good time in the rest of BriForum. So thank you very much.
Thank you.